Hey everyone, welcome back to the channel. So today we are tackling a really interesting problem from the LeetCode is 2327. Okay, and this is a daily contest problem where we have given the number of people aware of a secret problem, right? And that we will understand. So it's really a dynamic programming challenge that combines a prefix sum, sliding ranges, and a little bit of math intuition. Okay, and there is other approaches that I'll talk about in the last, right? So let's try to understand the intuition. So what is the intuition? So that I will discuss in the very simple steps, so don't worry. For now, first I am thinking to let's read the questions, because if you not read the question example, it's very difficult to understand. Okay, so very first the question is saying that on day one person discovers a secret. Okay, so there is a person, right? On day he discover a secret. Okay, so you are given a integer delay. Okay, so you are given an integer delay. As you can see, there is a person, right? And on day one person discovers secret, right? And you are given an integer delay, as you can see we have given here. Okay, which means that each person will share the secret with a new person every day. Okay, starting from the delay days after discovering the secret. You are also given an integer a forget, as you can see here, which means each person will forget the secret forget days after discovering it. Okay, so a person cannot share the secret on the same day, they forget it, or on any other afterwards. So we have given integer n, and it will return the number of people who know the secret at end of the day n. Since the answer may be very large, return modulo. Okay, we have to take the modulo of the result and then you have to return. So very first, what you have learned here, right? It is saying that on day one. Okay, so there is a very small story, right? What is the story is there? On day one person knows a secret. Okay, and after delay days, right, this person starts sharing it with a new person every single day. But there is a catch. After forget days, the completely he forgets the secret. Once they forget, they can't share it anymore, right? And the question is, after n days, right? After n days, how many people still know the secret? Okay, so since the question saying that it can be a larger value, you have to take the modulo. That is what the question is saying. Okay, can I repeat again? I'm saying on day one, the story says that on day one person knows a secret. Okay, and after delay, right? After delay means this is the delay that you have given, delay days. So after delay days, this person starts sharing it with any other person, right? On every single day. Okay, and after that, there is just very small catch, and that catch is after the forget days, he completely forgets the secret, right? But he can't share it anymore, because once he forget, he cannot share it anymore. Okay, so the question is, after n days, right, how many people still know the secret, right? And this can be a larger value, so take the modulo. That's all. Okay, modulo can 1 billion plus 7. Okay, so this is what we have to do. So if you see this example, you will understand. Give me a little bit. I will increase the font. Okay, so you can see the example. Okay, very first, what we have given, n equal to 6 we have given, delay is 2, and forget is 4 we have given. Okay, so very first, on day one person learns, right? Day 2, nobody new learns, right? And because this year is still waiting for delay is equal to 2 days, you can say, right? And then at day 3, the person starts sharing, right, with one person learns, right? Then one person is learning. Then at day 4, the person share again and another new person learns. Day 5, the person who learned on day 3 now starts sharing. So one person learns, correct? And at day 6, both day 3 and day 4 are sharing. So two people learns this day. Okay. So at the end of day 6, right, we check who still remembers, right? So day 1 person forget after 4 days, right? So they are out, right? So everyone from day 3 onwards still remembers. Can we say that? So that's why 5 people, 5 total people are there, and that is why the match is the expected answer here. Okay. So you can pause this example and you can understand. So if you see the question saying that it is taking when we are at day 5, right? Day 5. Okay. So when we are at day 5, right? So we know that we are taking the previous person also, right? So these things, as you can see, it is suppose the first person is named A. We can say one person. When we talk about a person who knows the secret is 1, right? Now it is saying a person share the secret with person B is 2. Now another person learns, that is C, is a 3 people, right? So if you see, this is a kind of prefix sum, right? Means we are getting the previous values added into the current one, right? That is why we have to use this approach. Okay. So the intuition is like we will use what you call each day, right? And the number of new learner is equal to what? Number of past learner who old enough to share but haven't forget it, right? So that we have to take care of, right? So as you move ahead, it is saying A forget the secret, B share the secret with the new, like D, and we are getting the value, right? And at the last we share with E, E share with F, and number of people is 5, right? It's basically intuition says here that each day the number of new learners is equal to the number of past learners who are old enough to share but haven't forget yet. So basically we look a window of previous day, right? And we can say what? We can say day minus forget plus 1 and day minus delay. So this is the range will become, means previous day is from where? From day minus forget plus 1 and the day minus delay, right? This is what is the previous date between there, right? We can say. And so this is a sliding window approach, we can say, where that will we can move every day forward, right? We can use the prefix sum also, right? So why we will use the prefix sum here? So we will use dynamic programming very first and the prefix sum, because we know that if we have the dynamic programming, we use array, right? So at array, how many people learns the secret at the day? So at each day we know the as you can see, right, person 1, person 2, it is getting increased each time, right? So we don't need to remember, right, how. So what we will do, we'll store somewhere, let's call dp array will use, and we'll say how many people, the learners on the day that I the day, we can say the index, right, he learns, right? And then we will have a prefix at I, where will a prefix sum of the dp day I will be added, so we can get the range faster. Okay, so let's try to understand. I'll show you the slide so you will understand. So very first, the question saying that number of people aware of secret, right? So day 1, one person knows a secret and each person starts sharing the secret delay after they learn it, right? And they share once per person to a new person, and every day while they remember it. So we can say each person forget the secret, forget days after they learn it, and they can they cannot longer share it, right? We have given n number of days, and after we have to check how many people still knows the secret at the end of the day, nth day, we can say. and we take the modulo, will return the result. So what you need to think that every day some people learn the secret, that is called new learner, and some of those learners will later start sharing after delay days, and that will stop sharing after the forget days. So you must count active learner at day n. Understand? Means we have to keep the count of the previous one also. So let's go through an example where we have the n is equal to 6, delay is 2, and forget is 4. Okay, so we'll track the using the dp at day, so that number of people who learn the secret on that day we will understand. So let's suppose this is your I, and we can say this is a day, right? So dp at day is a kind of index I. Okay, so we'll say this is dp day, and we'll have a day, and we'll calculate dp at day, means who learned that day, right? So dp at day or dp at I, we can say, is nothing but who learns that day will keep storing the value. Very first, the first person came here, and that is called initial person, right? So let's move to the day 2, where the person who learned on the day 1 can't share it, needs delay 2 days. He needs 2 day delay. Okay, so on day 1, right, that day 1 person can share now, one person learn, and day 2 the day person is still sharing another one, new one, we can say, right? Now at day 3 person starts sharing what, day 3 plus delay 5, right? Plus we can say forget on day 5, right? Now at day 2, at day 6 we'll say, okay, so he has already shared with another person, right? That person is also sharing. It means how many people here learn here? 2 people learn, right? By the day on the day 1 that we have learned, right, here, and another who learned here. So though both we have to, both here he will start sharing, right? So at day 3 and day 4 that who learned, that we can say he can start sharing. Okay, so here the dp is 2. Let's compute. So we can say dp at 1 will take is 1, and for day d, new learners are those who learn on day j will be become what, between these ranges, right? As I told you, j plus delay should be less than equal to d, and it should be less than equal to j plus forget minus 1. So j is between d minus forget plus 1, and it will become d minus delay. So mathematically, if you compute it, at day 1 we know that dp is 1, day 2 we have not shared with anyone, day 3 dp minus 1, dp1 is equal to 1, day 4 we have to compute it, dp1 and dp2 will get 1, and dp5 will say dp2 plus dp3, and you will get 1. Similarly for dp6 you will get 1 plus 1 is 2. So this is what you have to understand, that j will be always between d minus forget plus 1 and then d minus delay. The date, the new learner date will be, means we can say where we have to look into the window, right? Previous days. So previous days will be day minus forget plus 1 and day minus delay. This is what your previous days, right, where you have to look at the window, we can say. So this is our means we have to find that thing. Okay, so that is what, how we will calculate it. Now we'll still remember at the end of day 6, and we'll say, okay, people who learn on day j with is j plus forget should be greater than 6, right? We can say, okay, so j is 6 minus 4 plus 1 is equal to 3. Okay, so let's do the sum. So sum is dp from 3 to 6 we will go, right? And if we'll do all the sum, we'll see, okay, total is 5. So that matches our exact output. Okay, if you not understand, pause this, try to understand, and if you have any doubt, please ping me in the comment box. Okay, now let's try to understand the pointer movement. Okay, very first, the critical interval for day d is what? Left d minus forget plus 1, and so the right will become what? D minus j. As I just said you, the critical interval days will be from left to right. This is our ranges. Okay, so j between left and right are the people who can share on the day d, right? So as d increases by 1, the left increases by 1 and the right also increases by 1, right? So the valid contributing range is sliding forward by 1 day, right? Means there is a range also. Okay, so never thought that there is only prefix sum we will use, and the what you call dp at I we will use, and will not, that's done. No, you have to understand the concept that how the ranges is coming here. Okay, after that we will maintain a prefix sum so that the dp of j will cross the these boundaries, and so it will give you of 1 to compute it. Okay, if you talk about the example, let's call day 3, the range is between 0 to 1. For day 4, this is the range. Like this we can calculate the ranges, and you can actually include the actual dp. Okay, so this is our 2 pointers like things, where we will also use the sliding interval, means we can compute dpd from a prefix sum quickly. So there is a combination of multiple things here. So if you'll talk about the intuition, so we can say we don't model each person individually, that will explode, right? So instead of what we will do, we'll track how many people appears on day at each day, we can say. So for each day, let's suppose for d, the number of new people equals the number of currently eligible shares, who's those who have learned earlier and have they passed the delay days, right? Since learning haven't forget it, right? So what we'll say, our observation is, if dp as j is the number who learn on day j, then day d they contribute it. So this is what we have seen, right? And otherwise that gives the interval j between dp at d is equal to the sum of dp j between these intervals, right? And then we'll use the prefix sum to compute that sum pass. That we have understood this one. Okay, so for the implementation perspective, very first you will initialize these two things, dp and prefix, right? We will use, and what we will do, we'll compute for all the day, where we'll start from 2 to n, and then we'll find the left and right, you know what you need to do. And then we'll how we will calculate the dpd prefix right minus prefix left minus 1 we will do, and you have to take the model also, and you will update our each day. Okay, means that the prefix d minus 1 plus means previous day and plus current day, you will do add, and you will update the current one. Okay, so the answer is nothing but the sum of dp at j from j to the current value, so who haven't forget by the day, that we know the ranges. Okay, and this is what our answer will get, and it will give you offend time, and the space will also offend. Let's try to understand through the code. Very first we will define dp and the prefix sum as we have discussed. Okay, so dp at 1 is nothing but we'll initialize with 1 and 1, right? Because we have, that is why we have taken n plus 1 n plus 1, right? We know that how dp works. I suppose that you know little bit dp. Okay, so we'll create a dp, means there's a single array will we have, and it will store our previous values. Okay, so for day 2 is day should be less than equal to n, and we'll go day plus plus, you will find the left. How we will find? We will take the 1 and day minus forget plus 1. This is the left range, and this is the right range, means this is the day will come between the day where we have to count, right? Is between left and right, as we know. So right will be always greater than equal to left. In that case, we have to find the range, some range, where we have to find, means prefix sum at right minus prefix sum at left minus 1. This is what will give you the exact what you call the window of the previous days, right? And this is, we name it as a sum range. Okay, and we'll take the modulo if the values if the range moves in everyday big values, we can say. Otherwise we'll say I will take the sum range, and we'll keep adding the value here by using the mod, and we'll update our dpd as a sum range, otherwise it is 0. And at the last we'll take dp plus prefix sum day, and we'll get the value here, and we'll update the prefix sum day. Okay, and we'll keep moving ahead. Similarly, now we have to like people who we have to count the people who still know the secret at the day, right? Nth day we can say. How we are going to find it? So n minus forget plus 1 will do. We'll say start and we'll iterate over the j as we told. From the start to we'll go to n and we'll find all the people who knows the secrets. So this is our answer. We'll keep adding the dp at I because we have calculated here, and we'll get the answer and we'll return the answer. Okay. So there is a multiple approach we have still that we can do, right? Let me know in the comment section that you want to know. Okay. So there is multiple approaches there, like if simply who started the programming can go with the naive approach, a person to person model we can say, per person model we can say, right? Where we'll keep a list, or you can say queue, for every person with the day they learn, and each day we will iterate through the list we can say, and we'll check they have eligible, right, to create the new person. Yes. Okay. So this is a, we can say, direct simulation that we will do, right? And this is a intuitive way we can say. And the cons is there, like it's give you the exponential growth. That is not good. It's not healthy for the memory or time we can say. That is why we have used the dp with prefix sum we can say. Okay. And where we have used the dp, right, we'll store the new learner day by day, and we have taken a prefix sum we can say, and we have get the ranges, right? And benefit is that we have used O of one time or O of n time we can say, and time and space complexity is very simple to implement. That is why we have used it. Okay. Other than we can use also a sliding window approach, or using the circular approach, where you'll keep the an array or queue where you will have the forget, right? So each entry case stores the dp like that you can do. Okay. Other than you can use also a matrix exponential thing, like you can do that by the linear recurrence, right? You can try by that also. Okay. Let me know in the comment section that you want or not. So that's all. Thank you guys. Thank you for watching this video. I'll see you in the next one. Bye bye.